The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
Computers.
It's not that. Like, it's going to record like this and I don't give a shit at this point in time. Yeah. Cause everyone thinks that like, I was like, you haven't showed your face in 2 weeks. I'm like, yeah, that's because I've been traveling so much and my computer has a big freaking cross in it. And I haven't had time to go back. They'll keep yelling at me. I'm pretty sure they closed the work order out. They're like, are you going to bring it? I was like, when I get freaking chance, because like I had to bring it somewhere like in Dallas because I don't want to have to send it wherever. And yeah, I'm still dealing with that. So there's that.
Looks ridiculous.
It does. It does. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're your hosts, Brett Wetzel and Kevin Compass. How you doing?
Oh, it's been an exhausting week of just like random bullshit.
Everything's on fire.
Yeah, it's just that just trying to get caught up with like jobs, and it's just like random bullshit, just like fires everywhere. And like we've been having like nonstop power problems out here, so there's been a lot of brownouts. And I was working at a store yesterday, and I'm like getting ready to leave, and I'm like, motherfucker, the power just went out, and like it flashed, and I'm like, oh, don't you do it, I heard the racks all shut off. I'm like, ah. And then I just seen the lights start flickering. I'm like, oh, I hate everybody right now.
One time I was down in a store down in Florida, and yeah, it like all of a sudden we were just about ready to leave. We're all talking at the end of the day, just talking war stories or whatever, ready to duck out, and all of a sudden the lights start going disco. I'm like, this is a CO2 rack. I'm like, no. And we go out, and they're like, someone goes, what do you think's wrong? I'm like, dude, we lost a phase somewhere. And I'm pretty sure, I don't know if the schedule was actually working because that rack went off really quick. So just that.
Yeah, it's we've been like having like nonstop power problems out here, so I don't even want to think. Yeah, I'm just mentally exhausted. So what are we talking about?
I have no idea.
Probably should have done that before you started recording.
That's all right. Well, I mean, I hate you. Whatever. No, I have no idea.
We were talking about CO2 troubleshooting. We could talk about gas cooler troubleshooting, or we could talk about high pressure valve, or I don't know. Just go ahead and dive into it. Since you've been working in the field today, I see you're a little dirty. Oh, this must be new equipment.
Shut up. Such a dick. Nothing is ever good enough for you. Oh, you don't want to work in the field. Oh, you're in the field? Oh, it must be new equipment.
You're very clean.
Today was paperwork day.
Oh, paperwork day. Fitting for you.
Mother.
All right, start it off. How you get around?
All right, so I guess gas cooler troubleshooting, fine. All right, we'll start with, I don't know, I guess we'll probably have enough time since I'm all nice and clean to talk about, we'll start talking about the BAC. Gas cooler troubleshooting, we're typically doing a TV. Depends on who says what. Typically we use the ambient temperature sensor going into the pad. what some people have been doing is they've been using the post-pad temperature sensor as the ambient rather than the actual ambient.
I like it,
Yeah.
but only when it's in a spot where water's not dripping on it.
No, agreed. I totally agreed. So what I mean by that is, so pre-pad would be before, and usually for monitoring purposes, a lot of people will put another temperature sensor not connected to the BAC, but connected to whether it be the E3, E2, the pad controller. They'll put another ambient temperature sensor there underneath where the BAC actually has theirs mounted, which is typically underneath the left-hand side on the control cabinet. The reason for this, it's a good indication if the water is actually working. So on most of these, they have an enable. Let's start with the BAC. So the BAC has an enable for pre-cool function, which means it starts running the water once it gets up to 74 degrees. Typically, it has a 3-degree deadband on there. In this instance, the 3-degree deadband basically shuts off the water once it hits about below 71 degrees, but it has to stay that way for 10 minutes. Way it's factory programmed, right? But anyway, so the other extra ambient temperature sensor typically is put there for troubleshooting purposes. So someone remotely, if they know where the sensors are at and they're like, okay, it's 80 degrees. The ambient temperature is 80 degrees. So technically the pre-pad temperature should be a post-pad should be a couple degrees lower than that. If it's not, that's a good indication that I'm not getting water trickling down. Now, typically on the BAC, you have an input for your analog output coming from like your multiplex board, or your analog output coming from your pad controller to run the signal. Now, years in past, they used to do 0 volts, 0%. This is not a good thing, because if God forbid something happens with your analog output signal, those fans aren't going to spin if they don't get the voltage. So now it's been, a lot of people have been putting, and someone's going to be like, why do you do that? Because some guy gave me shit about it when we said this last time. But 10 volts basically is 0%. And then 0 volts is 100%. Like I said, if you lose your analog output module, I'd rather have the fans fail on than off.
Yeah, it's refrigeration 101. We always fail on.
So we have that. We want to make sure that signal's right. The signal has to match. You can program it you're going to have to program it in the either pack controller or the E3 or E2. And it has to match what the signal is, how it's programmed at the BAC. I think the password to get in for technician password is like 1703, I believe, to get into that. And that way you can look at all the stuff that's in there. So basically at 74 degrees, it'll start running the water. If anyone's familiar with the BAC, they're the only manufacturer out there that uses a pump. Fills a sump pump in the bottom. It's a 20-gallon sump. Fills up to a certain level. You have I
think the Heatcraft one does too now.
I don't know, because I heard the reason why not everyone else is doing it is because BAC has the patent for it. So the
patent on it.
I don't know.
That's what I heard. Something that's been around for 60 years.
I'm not saying it's right. I'm just saying that's what I heard. Anyway, so we're basically giving that thing, telling it to pump the water throughout. So some of the newer, larger styles, they'll have a trough on either side. It dribbles the water down across the pads, wets the pads, drops the temperature down to wet bulb, 3 degrees below wet bulb temperature outside. And lo and behold, we get a cooler air entering the coil. The water does not enter the actual coil. It just drops before it. Hence why we have that post-pad temperature sensor. So we know, in fact, that temperature drops above whatever temperature that the BAC is typically set. Also with the BAC, we do have a set of alarm contacts that you do have the availability to run back to some kind of input board to basically tell it, hey, I have an alarm, or no, I don't, and she's running.
I haven't messed too much with the BACs, just a little bit here and there, but they're also integratable to the E3 and E2, I believe, right?
They are. I know there was some issues with the one of the first renditions where they're basically communicating to it, like it wasn't reporting motor amperage or something like that. But that's basically what's that called? The integration.
Yeah, it's the integration from the PCO, Corel PCO. I'm going to be honest to you that I like the BAC. I like that it has the discrete header that you could hook up to a hose or override water if you need to. That is a killer, because if you bust a water line and you need to run this thing off of a hose, you can.
Now the new ones, or I don't know if it's newer. It is newer, but I think it's also what you pay for, right? they have the option, instead of just running a garden hose up to it, they have solenoids. Instead of just the solenoid filling it, it also has a solenoid that can go up and fill. So there is on the pump, because you're relying on this electronic pump to run. And if it doesn't run, there is a current sensing relay in there. It doesn't sense that there's running any current. It proof fails and then says, hey, we need to do something else. So either sends out alarm set of contacts, which will do. But it also has the option of putting a solenoid up there, where basically then it'll say, hey, we know we're not going to pump any water up, so let's just pump water in. And unfortunately, because it's not being able to recirculate, it will overfill and connected to the drain. There's a drain overfill. It's usually, I think it has to fill up like it almost 2 inches above where the actual level typically sits. And, that water will drain out, but at least, your rack's not going to go down.
Yeah, the street spray works pretty good. And then you're not going to get full flow, but like it's cold city water, so it's a lot better. But the thing here is the pumps aren't the most reliable. Like in the early ones, they had a lot of problems. But once you switch them out with a pump from like Menards or Home Depot, they seem to last like a decent while. But you got to clean the sumps, and that's where the pumps fail the most. If you're not cleaning the sumps at scale, it's just like a tower. Like it's gonna get. I don't care how much you dump this thing and flush it, it's gonna get scale in it.
So there's different models. I don't think all of them come with this option. So there is a continuity meter that you can put. So it looks like a little black pressure transducer. It goes on the water line right above where the pump is. Essentially, it's measuring the solids in the water. So you can set that to like if it hits a certain amount of solids. Because the reason why this happened is when you evaporate water, you're left with whatever's left, right? So if you're living in a very hard water area, they're going to be left with a lot of solids that are left over. Yeah, like up in Chicago.
Chicago's got hard ass water. So like the tubes plug on the upper headers, the spray nozzles plug, like all that needs to be maintenance. Like in the fall and spring, like you need to go through and check all the sprayers and make sure they're all good because they look like shit on all.
Oh, dude, I was up in Idaho. I'm going to bring up a picture in a minute. I was up in Idaho and holy shit. And the guy goes, we could treat that water, can't we? I was like, no, don't even have the guy come near it. I actually seen a picture and I wish I would have took the picture of the pads, but the pads like literally deteriorated because someone put a chemical in there.
Well, the Costco's do that. Like they didn't put chemical in there, but like the pads like disintegrated from the scale.
Yeah,
not BAC, but like another manufacturer. Like it literally just it looked like straight calcium, but this store was off of well water.
Yeah, Ref Plus does something similar, but what they do is they actually just spray like they spray water away from just a regular dry cooler, like a dry gas cooler. And basically what happens is they spray it out enough that the water atomizes and then it it evaporates and then cool air gets then sucked into the dry gas cooler. The problem with that is I don't know how it's going to fare with windy areas like Texas, Chicago, how that would work. But one thing that I do really agree with them on is the fact that they utilize almost like a reverse osmosis type thing where it pulls out all the solids. Can't use like a softener because then you're just left with even more salt within the system.
The reverse osmosis, I thought that eats copper. It doesn't? I thought you couldn't run reverse osmosis lines in copper.
No.
Yeah, I'm almost positive because all the RO lines over here are always plastic. Even in the city, which...
Okay, then, all right, so I might be wrong on the RO, but I do know there's a whole bunch of particulate filters throughout this thing. There's 3 or 4 within the Ref Plus unit, and they make you buy it. They're like, you can't get this unit without this, because then they won't warranty it, because if it does get any particulates on there, it's going to be all hard water, you know what I mean?
It looks really cool. It looks simple. That's my thing. With these gas coolers, the more complicated you make, the simple. I don't understand why none of them have figured out motorcycling yet. They're all just, it's taboo. If they could fix
You said, what did you call it?
Motorcycling. Like the motorcycling.
Motorcycling. Oh.
Oh. Yeah.
I thought you meant, we were talking about water, and I'm thinking motorcycle. Like, motorcycle. Not what you're talking about.
Idiot.
No, I was like, that's why I'm like, what are you talking about? Like, where do we go from this?
Yeah, no, the motorcycling on the gas coolers is by far the biggest problem. I wonder if some of these EBM motors and everything are failing to prematurely because of the moist water air getting in there. Oh yeah, that's what they look like. And you
How
can see,
delicious is that?
like you see the tubes, how shitty the water flow looks in the tubes. They coming down. Those need to get cleaned out.
Look at that.
Yeah. Look at the top. Look at the top of it.
Oh, rough. It's gonna start eating away. Like I said, Idaho has really bad water.
It's probably well water.
I'm not 100% positive, but you can see shitty water nonetheless. I don't want to keep cycling through the photos because I really don't know what else. It might be another message. You've seen our chats.
Just pictures of Dylan
in a dress, the wig, yelling at a wall, hoping it changes its mind.
Oh, stop it! He's gonna hear this.
Yeah, I know.
Yeah, as like the adiabatic troubleshooting, if you're losing pumps, you more likely have a solid issue inside the gas cooler. Clean it out. It needs to be cleaned out every spring and fall. Make sure it's good. Make sure it's flushed. Make sure the sump is properly adjusted and you're not losing water or losing your prime.
Here, yeah, keep talking about that.
So make sure the float ball, there's a float ball in there, just like a standard tower. And as it drops, just an oil float, as it drops, it works the opposite. As the level drops, it's going to release the tension on the float and it allows the needle to open up and allows water to come in the tower. And as the level rises, the ball pushes tension back on the needle and closes off the line feeding the tower. Super simple, but make sure it's adjusted properly because you need to be over a certain spot in the pump to prime it. So you need to get high enough to prime the pump because if you're not high enough with that level, you're not going to prime the pump. And then you're going to run dry.
So the other thing is there is delays, and that's what I'm actually going to bring up right now. There's delays in the pump to basically overshoot a little bit because you don't want to keep cycling. There's on these BACs, there are two valves. There's one normally open BLEMO type ball valve, and then there's one solenoid that it's the fill. That fill, we have that energized whenever we go into pre-cool, but like with that overfill that's in the basin there, we want to fail it. We want it to keep pumping for a little bit longer, even though it senses a level. And the reason for that is because we don't want to keep short cycling that solenoid. So let me bring up get rid of that bad chat. Present. Shift screen. Window. Bam. There we go. So can you see that?
Yeah.
So right over here, this is essentially what the basin looks like. You have your pump in here. Mindful, there are holes all along the outside of the pump, but actually underneath, there's going to be a certain amount of holes. Those certain amount of holes basically tells you how many fans it belongs with. So if it has 3 fans, then it's a singular pump, then it's going to have 3 holes right in the middle of the actual pump. If it is a 6 fan, you will 3 fan over here, 3 fan over here. You'll essentially have three holes on there, but you'll have 2 different pumps. Over here, here's the normally open ball valve. They keep that normally open because if God forbid it gets water in there and gets below and it does, it wouldn't activate or whatever, then it would basically purge out all the water so it doesn't freeze. This is the overfill pipe that we were talking about. What you want to do is once this float energizes, it basically says, hey man, I got enough in here, you can shut off there. But sometimes what you have to do is play with the delays in there to let it fill just a little bit more. Now you don't want to keep changing this out, because theoretically you should have a set pressure on a regulator that's feeding this. So if it starts not filling enough, you just want to increase it. It's probably having to do with whoever set it up in the beginning, set it up for when it was working perfectly. And now with wear and tear on all the different components, it might not be filling it up enough, something like that.
Can also the engineers designing this stuff, if you're listening, please spec heat tape on the water line and in a drain and bleed, and please stop using hot water lines.
Today's episode is sponsored by the RefRush-Shield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. but replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Have you seen the hot water line?
Yeah. I've seen it in another store the other day.
Did you really?
It was spec'd that way, and I'm like, what the fuck?
What?
Yeah. She wasn't tying right in the hot water line. I'm like, ugh.
So these pads are incredibly heavy when they're wet.
Oh, they suck, dude, when they're wet.
Yeah. Oh, dude, so even though it went through its rinse cycle for however long when the fan's still running, they were still swollen. So we had to take it out because we had to prove that post-pad temperature sensor is basically somewhere behind here. And as you can see, like this is about the same size. This one will be a little bit different. The one that's going to be different typically has yellow paint at the top and telling you that's the first one to go in. So that picture before, stop grabbing the goddamn picture. So on the first picture I showed you where it was all corroded, this one's just a piece of PVC that has a whole bunch of holes in here. These holes do get blocked depending on how much debris you have. So just be mindful of that.
Yeah, no, like those things are a pain to clean too. Like you could wash them, but like they start deteriorating, especially if you power wash them.
These are a lot of different screens that you have. Oh my God, stop moving stuff. Jesus, don't see. I didn't plug in my mouse, so I'm struggling here. So anyway, stop it. God, anyway. So right here we have the analog the outdoor air temperature. Get away from that. We have the outdoor air temperature and there's our temp differential. So there's this one sets for 75, 3-degree diff. So basically once it's below 72 degrees, but it has to be below 72 for 10 minutes. Not every single one utilizes the next thing over here with the high head pressure alarm. That's only if you're using some kind of pressure control. This is the pre-cool mode delay off when it reaches set point. So I have to ramp up, ramp down. I think this has to do with this part of the menu here. Someone just died next door. Oh no, that was the ice machine. Anyway, and then right here you have pump on delay, pump makeup delay, pump on delay. This is where you might increase it a little bit just to let that water fill a little bit above right before it gets to the tippy top of the drain. Because what happens is when the pump comes on, it's going to drain a lot of that water, right? So instead of having it cycle that makeup water solenoid back and forth, blah, 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 then you don't want to do that. We also have the pump fail delay, pump pressure fail delay, and makeup fail delay. And over on the other side on the diagnostics, we also have a periodic drain. This one is a drain for 120 seconds. The interval is actually 2 hours. The reason why it's 2 hours is because it wants to try to dry the pads off. It's set right now for 2 o'clock in the morning. Make sure that says 2 o'clock in the morning. And if it does say 2 o'clock in the morning, make sure your clock is right.
Oh yeah, that would suck. 2 p.m. would not be the time to be doing that.
Yeah, 2 o'clock and almost the hottest part of the day. Let's just shut the water off. So yeah, let's not do that. This doesn't have a temperature delay, unfortunately. One of the other options that this tower does have, or the BAC gas cooler does have, is you can actually run the fans backwards to try to push out the debris, which
everybody does that. Everybody's tried that. I've never ever seen it work.
I think if you had like the pre-pad, like on the Munters unit, they have that black filter material.
That would be awful. Those things plug up so much.
I understand that, but then it wouldn't. No, but it would be better because then it wouldn't. The cottonwood and stuff then wouldn't go to the wet pad where it turns into freaking concrete.
Yeah, then you'd be there every week cleaning that thing, especially if I'm
not every week. But what I'm saying, it's better than having to clean the pads every week. Would you rather clean the little plastic thing, or would you rather clean that? Yeah, make up your mind.
Make the apprentice do it.
That's my point. So what I'm saying is here. So on that self-clean function where it reverses the fan rotation, those ones actually, you can actually set a temperature, like, so you won't have it do it above 75 degrees or something like that. So once we start using water, I'm not going to do any kind of self-clean function. You can set a time for that, but also let's just not do it when it's hot.
Yeah, no, I was wondering about that because I started looking through that. I haven't really messed with it too much, but yeah, that would suck if it was still 100 degrees outside, like in Texas.
100%. So there's your auto discrete open valve because normally up here at the top, there is just stop selecting things. So up here at the top, you have the auto discrete solenoid. So if it proves that there's a pump failure, there's a valve, a Belimo valve right above the pump that will stop it, that will close, and then something wants to get thrown today. Once it proves that the pump has failed, it'll close that Belimo valve, start feeding the solenoids at the top, and just run it and just drain it out. The drain valve at that point will be open. Otherwise, right where it says auto discrete, that's where you would essentially have to hook up a garden hose if that option does not exist.
Yeah, and it works pretty good. It's a great backup, but as long as there's a hose bib close on the roof.
Usually there is, right?
Yeah, I haven't seen it on a lot of the stores like Prince. I know Target is pretty good about it, but I've been making the plumber. I go buy him he got mad and wouldn't go to his mouse. I make the plumber install a hose bib on the water feed line. Like I will give him the hose bib pieces, and that way he can put it in on the water feed line, because it only benefits us to have a hose there. And then I leave a 25-foot hose on the roof with a garden hose connection. There's no reason nobody should be not cleaning the gas cooler at that point if there's already a hose up there. I mean, that was like a great thing about Aldi when they started putting all the hose connections right next to the rack. You leave a 25-foot hose up there, and you could easily clean everything.
Go ahead, keep talking. Still looking for the mouse.
But yeah, other than these, the BAC gas coolers are relatively simple. There's not a ton of programming going on in the background. The only thing that gets like weird is you got the motors are communicating with the corral, so to do their speed, so they're communicating over Modbus. So that's where it gets a little convoluted and a little bit more difficult to troubleshoot.
Yeah, so if you look at this is the schematic of the Z-Lavic motors. So you have the ground A positive, B negative. Basically, this is your Modbus line communicating. This is the 45. So all these are actually communicating together. I know it's not the full schematic, but the reason why is because the schematic is long. So unless you want to look at it like that, which isn't going to be helpful to anyone, that's why I have it broken down in pieces. So yeah, so basically Modbus is from this controller right here. Here's some of the stuff that's in the inputs here. You have a float input, manual pre-cool, and the pump current switch, which is basically your proofing switch for that pump. Right down here, you can run these fans off of 4 to 20, 0 to 10, or 10 to 0, and then there's your general alarm output relay that you can use for a DI on your main BMS controller. And then every other thing on here, pre-cool, float switch, I believe everything here is 120. Yeah, because there's another transformer, because it steps it down from 480 to 120 to 24 volts, I believe. Yeah. So oh no, never mind. So the dump valve, the fill valve, pump valve, discrete valve, all that shit should be 24 volt AC. I think the only thing that's actually 120, if I go one more up, yeah, the only thing that's the pump.
Yep.
Yeah, there's that. But like I said, essentially what we're doing is, the water is all being controlled by BAC. The only thing we are doing, we're giving it set points in that, but the only thing we're essentially doing is basically giving it a signal to basically run the pump, to drop the water across the pad, take that warm air to make cold, humid air. Now, places where it's humid, it's not nearly as efficient as what it could be.
Oh yeah, they all sucked last week or the week before last when it was 100 degrees out here and it was humid. They were all struggling big time.
Really?
The BACs did better than the others. It's just because BAC dumps a lot more water on the pads because they have the pump. So they aren't just dumping a little bit of water in there. I think the pads work a million times better on the BACs because they're completely wetted. And they're not just...
See, and I still haven't cracked the code. So I guess we'll switch over to Güntner if you want. What we can do is, unless you want to keep talking about BAC or you want to finish off with Güntner, just the differences.
We could talk about the differences. Güntner, with theirs, they don't have a pump. They just take water and they have a calculation based on dew point and water flow and...
Hold on.
What?
Not on every single one.
Yeah.
Not on every single one.
No, everyone that I see has that set up. So everyone that I've seen at like Sam's and Costco and everything else. So this is how they do the water in these. They have a dew point calculation, and they're using that with water flow to meter the water going down the pad. So there's a minimal amount of water going down the drain. It's supposed to be a minimal amount of water going down the drain if they're set up properly. So it's supposed to wet the pads just enough during that time. So the more humid it is outside, the less pad wetting you're going to get because it's not going to evaporate it.
So what I was going to say is, so there's basically two different methods of what it does. So one is what you're referring to. So let me bring up the easier one. So all it does is bring on the water. It enables at a certain temperature, doesn't start letting it go until the fans get to a certain speed, and then we'll shut off when the fans ramp down to a certain speed. That's one method. And then the other one that Kevin's referring to is that they have a post-pad temperature sensor, but it's also a humidity sensor. They're trying to make sure, essentially, their water conservation is based off of, I believe, trying to maintain 100% relative humidity. So it knows based off of how much what the humidity is outside and humidity after, basically being able to tell what is 100% relative humidity based off of that. And then it is also still based off of fan speed, if I'm not mistaken.
Correct. There's a threshold in there, and if it's not met, then it starts cutting back the water, shutting it off.
Correct.
But it is measuring the humidity, and that's how it does it. And it's supposed to optimize the pad wetting, so like that way they aren't using more water than they need when they already have 100% humidity. So it's already 100% saturated. So in theory, it's not going to get any cooler.
Correct. Because you can only pump so much water through if you have, if you're already at 60% humidity, then guess what? You're not going to over soak the damn thing for that. You know what I mean?
That's why if you're troubleshooting one of these and it does have that system, you need to verify both humidity sensors and make sure they're reading properly, or they're not reading open or anything like that, or reading off, because it's going to affect your pad wetting.
Yeah, because one of the controllers is doing all the water on the old. Okay, so
Yeah, the newer ones, it's all together.
It's all in one, yeah. But before, it was one was controlling the water, the other one was controlling the fans.
Yeah, it was the GMM does, I believe, the fans, and then
Güntner motor management, and then the other one's
GMO.
What?
I think it's GMO or
GHM, I think.
GHM.
I think it's Güntner humidity monitoring, I believe.
Yeah.
It looks, hold on. I'm trying to
They look very similar to each other. Just one had the inputs for the humidity sensors and one had the inputs for the fans on there. Now they're combined into one. So they're doing the motor management and the pad wetting all in one.
Probably makes it easier to figure out like what's going on with it.
Oh, I'm sure.
Oh, that's not what I'm sharing. Idiot. Okay. Remove. I'm getting there. Stupid. Stop screen.
You find your mouse.
Yeah. I'm using my mouse now.
I was wondering you were gonna crack.
Oh, I cracked. Definitely cracked. Chrome tab. There we go. That's the GHM. So I was trying to figure out like how to optimize that, and like you gotta talk to Will and I, because I had theory about it, because you don't want to under wet the pads where you're only utilizing just the top end of the pads. You want to be able to utilize the whole thing, but that's what that flow meter is for, and that's why like whenever you start one of these up, call freaking Güntner. Call Güntner.
I'm not gonna lie though, the last two I've started up, they seem to have fixed their pre-shipping program issues, and the pad wetting is close to spot on.
Okay, so right here, so you can see it takes the ambient temperature, air moisture, I think it's the post-pad temperature sensor, and the communication to the condensing pressure if it's doing that. So we're only just doing the top two. That's fed information to the GHM, which then is controlling the control valve and basically flowing X amount of water into there to fully wet the pads.
Yeah, it's if you see a ton of water going down a drain, you're gonna have some. Then you need to call tech support and get a hold of Will and have him troubleshoot this with you. Either the sensors are not reading right, they've had some sensor issues, or you have improperly commissioned / program water setup, and your liters per minute may not be set right on the flow. There's a flow meter on there, or may not be working properly. So that's one thing to keep in mind with these. And then same thing, like you got to take them apart and look behind them. Don't be lazy. If the head pressure is high, pull the pad and see if the condenser is plugged behind it, because generally is plugged.
Yeah, you can see in this picture, see this, I'm actually can move because now I have a mouse. But you can see we were barely wetting any of the pads. On this particular one that I was on site for, you can see it wasn't wetting shit over here, wasn't wetting shit over here because of blockages within there. So it depends on that humidity sensor, if I'm not mistaken, is usually it's on this side of the controller, where the controller is. It should be on the other side or whatever. So if you have portions of this where it's not wetting, it's thinking that it doesn't have enough water, so it's just going to keep pumping more and more water, just trying to saturate it. So that's why it's so important to make sure that the holes that are actually doing this are working properly.
Yeah, they use that weird green pipe, that fusion pipe on the top over there. So if you break it, it's a pain in the ass to fix.
I don't think I have a picture of that, unfortunately.
Yeah, it's poly fusion.
Oh, right here.
Yep.
So there's that water regulating valve that you were speaking of.
Yes. And if the system fails, say you lose the humidity sensor, something gets jacked up, what you can do is take that water regulating valve and either flip it the other direction on the BLEMO for clockwise, counterclockwise, and it'll give you full water flow. You don't really want full water flow, so what I usually do is get it to open some and disconnect it. So that way it's, say, like 10-15% open to where you have enough flow.
But isn't there a way I'm pretty sure there's a way to override the analog output in that GHM, if I'm not mistaken.
I would feel more comfortable, because what the power goes out and it wipes it out, I would feel more comfortable with just a manual dial percentage. Yes, there is. You can go into service mode. It sounded Canadian for a second.
It's all about that.
Yeah, go into service mode and you can adjust it there.
Gotcha. So you can see what proper pad wetting looks like here versus meow.
Yeah, a lot of these, it just comes down to keeping everything clean. I think the more you clean these things, the better off you're going to be. The only thing that's tough with these is, like, the coil's pretty thick on these, so if you got to power wash them, it takes a while.
So one of the things I was going to do today, which maybe I'll do tomorrow, the one that I'm going to train tomorrow was just started up not too long ago. What I'm thinking about doing is taking a manometer and seeing what the pressure drop is across the pad, and then what the pressure drop is from the pad, or I'm sorry, from one side of the coil to the other side of the coil, and seeing like what the typical pressure drop should be. Because that would be a good indication to tell you if you got some kind of issue with any kind of like internal.
Yeah, but wouldn't that slightly change with the fan speed?
That's why I was going to FAFO. I was just going to play around with it and be like, let's try this. Or I've never tried this before.
It would be cool at full fan speed if you could say, okay, there's a differential meter on here and it says plug condenser. Like, I would think at full fan speed, it would be the only one that matters. Because, hey, I'm at full fan speed, head pressure still climbing, differential's high. Get somebody out here to clean this damn condenser before it trips. They'll show up after it trips. It's true.
Yeah, it could cause the motors to burn out too, right? If you have...
Yeah.
Yeah.
I am not the biggest fan of these German motors, and we have never had good luck with them out here. They're too hard to get.
Sometimes they run fine, but then when you have areas that have shit power or fluctuating power or continual brownouts,
they don't last.
And so one of the things I found on one site where they didn't disable the fan signal upon a phase failure. So it was still trying to run it. And if the controller is having the phases that it needs to keep it rolling, you know what I mean? There's a good possibility that it won't think it's off. You know what I mean?
Yeah, that's become a huge problem. And the fact that those motors is, I don't care what you do to seal them, they all seem to leak water.
C'est vide.
Yeah, you could sit there going, and now the problem is we're spraying them with water. So we're putting more water into something that is already water prone to flame.
We're not spraying them with water. All we're doing is pre-cooling the air. Technically, it shouldn't be anywhere near the coil, which means it shouldn't be anywhere near the fan, right?
Yeah, those fans are all covered in humidity.
You're covered in humidity.
I'm a big fan of throw a horse and a half motor on a VFD, make it more simple, make it cheap to fix. When 5 of them burn out, you can go right and get a supply house and get a motor. Until they start stocking these, like the only place you're getting them is an OEM, and if they have them.
Apparently parts tech.
Yeah, I had 4 burn out at an Aldi after a power outage one night on a brand new rack, and I just started up. It made it like 3 months, and they had a power outage, burned all the motors out, and I had 4 Harbor Freight belt drive motors on top of it, and then I made it water cooled at the bottom. She went on the sprinkler, and once she gets on the sprinkler, she ain't coming off the sprinkler.
It's like an addict.
It is.
Sprinkler. I need that sprinkler.
They're all, once they go on the sprinkler, once they get that taste of that water, they're done.
So bad.
What? It's the truth.
So fucking bad.
Anytime anybody puts a sprinkler on them, they get the taste of that water, and they're never the same again.
That gas cooler pressure works amazing with that water on my car.
Don't do it.
Yeah. The oil issues went away because your pressure went down and you have other issues.
Maybe it's tuning, Kevin.
It's
Maybe it's all about tuning.
the oil issues with the high pressure is definitely tuning, but it's another conversation.
I was referring to it.
All right, I guess we're going to go on that one. I'll talk to you guys later. Have a great day. Have a good one. Bye.